Hey guys, this looks like a fun one. We're given 8 to the 3 to the I to the 2 to the 4 to the 0, and it wants us to simplify. If you want to try it on your own, pause it right now because I'm going to solve it in 3, 2, 1. This is a power tower, and you evaluate these by going from the top down. So we're going to do the 4 to the 0 power first. Anything to the 0 power is equal to 1. And typically this is how it's explained. You have something like 3 cubed, then 3 squared, then 3 to the 1, then 3 to the 0, 3 to the -1, 3 to the -2, and so on. 3 cubed is equal to 27, 3 squared is 9, 3 to the 1 is 3. And you'll notice for each row, we divide by 3 each time. So to get 3 to the 0, we're going to divide by 3. 3 divided by 3 will give us 1. And that's a quick demonstration why 3 to the 0 is equal to 1. And if you want to learn about negative exponents, we can go even further. 1 divided by 3 is 1/3. So 3 to the -1 is 1/3. We can divide by 3 again and we get 1/9. So 3 to the -2 is 1/9. So this isn't exactly a proof, but it's a pretty cool demonstration. And we could change the 4 to the 0 into a 1. Next, we're going to focus on this 2 to the 1. Well, 2 to the 1 is equal to 2. I don't think we need to talk about that. Next, we have I squared. For the most part, people use two different definitions for I. They say either I is equal to the square root of -1 or that I squared is equal to -1. There's some people who don't like this definition, and there's interesting reasons why. You should be fine using this as a definition for I. If we focus on this blue one, copy it down, and then square both sides, the square root and the square are inverse operations, so they're going to cancel each other out. And we're left with I squared is equal to -1. Regardless of which definition you use, they both tell us that I squared is equal to -1. So we can change this I squared to -1. Next, we're going to do the 3 to the -1. And earlier we demonstrated that 3 to the -1 is equal to 1/3. So we can change this to 1/3. And now we have a fraction as an exponent. These are called rational exponents. Here's the notes for rational exponents. The denominator is the root and the numerator is the exponent. So this 8 to the 1/3 can be rewritten as the cube root of 8. This denominator tells us the index of the root. And if you want to see a demonstration for these notes, we can do that as well. We go back to our 8 to the 1/3 power and set it equal to x. I don't really like fractions, so to get rid of this fraction, we can cube both sides of the equation. This 1/3 is going to multiply by the 3, which gives us 1. And then 8 to the first power is 8. Now we have 8 is equal to x cubed. From here, we can cube root both sides. And on the right-hand side, this cube root and the cube will cancel each other out. So we end up with x is equal to the cube root of 8. And that's the same thing we had from the notes. And from here, the cube root of 8 is equal to 2. This is the answer to our question. Let's put a box around it. How exciting. I was thinking about this problem. There's a couple changes I think could have made this more fun. If we change this 4 into a -4, then there could be kind of a debate because we know -4 to the 0 written like this is -1. And -4 to the 0 with this in parentheses is equal to +1. So how would we evaluate this? Would it be +1 or -1? I think the answer to this would have been +1. Because I believe there's implied parentheses at each layer of this power tower. Another thing that could have been cool if we made this an I to the 10th, then we could show the periodic cycle of imaginary numbers. I squared, I cubed, I to the 4th, and then it repeats again. I to the 5th is the same thing as I to the 1st. And here are all the values all the way to I to the 12th. So I to the 10th would have also given us -1. And we could have talked about the periodic property of imaginary numbers. I think this might have been a more fun problem to do. This also kind of has a fun shape to it. And here's tomorrow's question. Is 2 to the power of x times 6 to the power of the quantity 2 minus x over 15 to the power of the quantity -x minus 1 times 5 to the power of the quantity x plus 1? And it wants us to evaluate. How exciting.